this motor. Now I need the torque of this motor. It's ZD, not SPG. Induction motor. Okay, see that this model GNC, this model of our motor. Okay, this same number on level. Okay, the same number that on level. Now if you need to see starting torque, see starting torque with 200. Okay, starting torque with 200 up to 315 torque. Okay, what's the value? M N by M, Mn by M. Okay, M meter, and what's the Mn? See, Mn point M. To kilogram centimeter. Conversion table. This milli Newton. Okay, you can get N Newton, Mn millinewton, Kn kilonewton. Okay, Mn have 200 Mn to kilogram force per meter. You can convert it kilogram force by meter, this one. Okay, so if you need to apply some conversion of units, go to website and select unit converter and put your original unit in catalog of your equipment that you will use to convert it to something you can use. Okay, you can change Newton meter and change it here. Right click, edit definition, we need this 1 Newton meter Nm and change the same 0.2. and check. You have the values of it. 0.003 millimeter displacement, nothing. Okay, but this force, this torque, was the torque of the motor itself. This unit only. See? Only this one. Not with gear. Because gear have a high torque. Okay? So you have two somethings. You have the motor itself and the gear itself. Okay? If you have the main catalog, you can find the gear torque. Alright? Clear? Now, if you need this model, this 3D model, to be a model, we can create something here called, where is it? They changed the place. Simulate. Features, import options. Change the place, change the position. No. Let's check it out. No component tracker. Okay, we will see later. We'll see it, no problem. Okay, now if you need to make a report, export a report, here you can report this appendix will be the index, and this will be all results that you have here. Designer name, Unigraf, company, example, Unigraf, URL, for example, logo. If you have your logo, you can add here. Address, add your address, phone, all data, and your comment. If you have a technical comment, recommend something. Okay, recommend that this, no, it's so good, it's not okay, whatever. If you have any external data, you need to do any drawings 3D, you can send. Publish. A4. Be on desktop and A4. Enter past logo, sorry. You don't need to publish. This report. with all pages. And you can write your conclusion. Here, specification: the mass of part, volume of part, density of material, and weight, all data. And the properties: material, the model type, yield strength of material, tensile of material, elastic modulus of material, mass density, shear modulus. This is a full report. You can release and make an imprint on it, and you can get it to client. And what's the operation torque, what type of load, and load image, number of entities, sorry, what I meant, number of entities, value of torque, okay, all right, clear? No, I haven't a network. If you have a network with domain and you need to something in collaboration, if now مثلا for example you make a simulation on your computer, okay, and simulation will take time because it's very large, for example, okay, and Hector computer is free now, okay, you can make your simulation at your computer, okay, and start simulation, run the simulation, okay, but use the performance of Hector computer. Use the performance, he will push, okay, he will pull up the performance of Hector computer and make the rendering on your computer. So you can minimize your simulation normally and start working in another software. Okay, this is called for network, managed networks. You can make it through network. Okay, all right. Now I model only. No, I search about something would be good for you for sometimes. You may need it. No. Maybe remove this version. Why?
If I want to download, there is download that. I want the wind load.
Wind load?
Yes.
Yes, you can do. But wind load here expressed, wind load here expressed as a load. In wind load, you can use static, the same. But when you use static, you will apply something called pressure. External load, right click, pressure. Because wind load, yes, wind load is a pressure. Why? You have a specific force with total area of banner. Okay, it's very important. I can show you some example for it. Good question. Save it. Save this file. Very important. Very. I'll show something not complicated, but concentrate with me. Something good. Really good question. Okay. Feature. We have foot plate with, for example, 200 by 200. And another foot plate. Sorry, 1 point again. Okay. Through this point to this point, have at least banner with 2.5 meters. Okay. With 10 millimeters. And we have round column with 130. With 4 millimeter, for example. Okay. And one. How many? Height, for example, 3 millimeter. Okay. Now we have two bodies. This one body and this other. Okay. From first time, you can do that. Not need this. Not needed for construction. Okay. Now, because have an error, because only we will select this one, and this one already construction, so we don't have. And we have here what's the problem of this sketch? No problem. It's just a plan. Okay. With we can mirror it. Now, if we show plan from here to here with a plan, I think that we made new plan before. Okay. Delete plan. I need a parallel for this plan, right one, up to this point. Just click on point and click OK. Mirror body. This mirror body, not merge because this body separated with another. Now right click, material, ST37. Hide these sketches, hide this plan. Now we have two items. Okay? And these two items have a banner between them. Okay? For example, text, sketch, sorry. For example, have a banner like that. from this plate, or actually from here. To here. Five millimeter, for example, and this height for 1.5. And the thickness of banner mid plane will be divided into two planes, 0.1 millimeter. 0.1 millimeter. Okay, now we have a pressure in this area, and we need the effect on these columns. Can support or no? Yes? Okay? That you mean or not? Yeah? Hector, it's okay? Clear? And Noli, clear? Arbab, it's okay? Save. Similar study. First, before anything, you should know sure that you have one body, not multi bodies, because if you have multi bodies, you have another conditions. Something we need to make, and I will check with you if you have multi body, what you can do. First, something we missed. First, we need to make holes, fixation holes. It's very important also. You can use and you can't use according to the accuracy of calculation you need. So 0.5 will be okay, no, not needed. This phase, no need, equal, for example 60. So and check with this, it'll be okay. Why? Because we selected body. Okay, we selected before the body. Okay. Control S, save, and start simulation. Static. First, in fixation, you can have two choices. First, you can fix it, fixation geometry, from these points only. Like reality, your real situation, the fixation will be only on holes, not full plate. Okay? Or click all face. But for more accurate, also check the plate will be bent or no. Only these fixation points. External loads have a pressure on this face. This pressure on this face, how many? This is very important. Value of pressure. Now you have a wind load, okay? And in wind load, to calculate the actual force, you can't get it from calculation by mathematics. No, you have a catalog according to the standards you use. Use European standard. You have a book for European standards. Egyptian standards. We have a book in Egyptian standards. Okay, so you can get it from website. This value also linked with the zone, the area, in which place in Dubai. Which place in Dubai?
Yes,
Okay. Okay, and what's the height of area? Okay, it's normal floor or mountains, things like that. It's very important. Some data is very important. Okay, so you can get it from I think in government here can give you this data. It's very easy to get. For example, map. Get complete address. I don't know if you can find it or no. Yes. Found. Alright. Get wind speed. In Dubai, yes, in Dubai. Enter complete address below. Complete address. Jabal Ali. Jabal Ali. That's okay. Decimal value. It's generated automatically. You can get your wind speed. Yeah. Get wind speed here. What's the wind speed? This is 3 seconds. What? Big gust in mph. No, need to ground snow, no wind speed. We have another in Florida building, no. Wind speed, wind load in kilogram, centimeter. Yes, run this one. Wind speed in meter in second. Meter in second. Okay? Can't affect the pressure. Newton at meter square. We said before that Newton at meter square can be converted to kilogram to centimeter square. Okay? It's just unit. Okay? This means that this speed of wind affects this number of pressure. Okay, we need only this pressure. If we will go with the maximum wind speed, it's a very large, 32.6 meter in second. It's like something called what's it called? Storm. Yeah, it's like storm. Okay, if we will go with this, I think he told us in this one 3 seconds. We may get this one 3.4. Affect this number of Newton meter square. Right click, copy this number, and to go to here, Newton meter square, same value. Get it here. It's okay. Run. Okay, what's this message? It's very important. Before jump to this topic, I will explain this to you. Yes. Control C. This is good table for you. It will help you. Include table. Okay. Okay. It's okay this one. Get speed. From speed you can know the pressure. And here you have the equation if you need to calculate it. Okay. The pressure equal half x density half by density of air. This density of air. Standard value, okay, by wind speed square, this wind speed square, okay, by chip factor, and this chip factor is standard in books of standard of norms, okay, and we can compensate it with one, no problem. All right? Okay. Very important thing here. Why I have an error? Read this error, please. Read this error.
Meshing failed terminating analysis.
Okay. What does it mean? Sorry. Okay. So there is a strategy of softwares that make stress analysis. The software to make this stress analysis and to get you this result with flexibility you show, okay, should make something before called meshes. What's a mesh? Convert this surface to a million of points, okay, and apply the force equation on each point of this million of points. Okay, after that, these points will get a deformation, and you see finally the shape like that. Okay, so now in complicated shapes may have this error. This means that you need to make this mesh step, make it alone manually. Okay. First, we click run. Software automatically create meshing and start solving. Do 2 steps in 1 click. Okay? But in this way, you have a problem in mesh. You should make mesh manually. Okay? And click run only. Right click on mesh, create mesh. This mesh density. If you will make it fine, more time to resolve. Curve, low time to resolve. Okay, the mesh density. Now, because we have some small areas and some small connections, we should make it refine. And get okay. See. Okay, we have a problem. Check. Where is the problem? Your problem in post extrude 4. Your main problem in post extrude 4. This post extrude 4 have a problem with mesh. Okay. So what can we do? Right click on mesh. Okay, go to mesh parameter and then change something called triangles of mesh. Okay, I'll explain something very important. What is it's okay? If you have a face, just face, okay, surface face, and you need to apply stress analysis, what's the mesh? Create small triangles. Triangles, okay? This triangle have a size, okay? You can control its size from here, okay? Why? Because if triangle size here is 52, 52 can be okay, but not be okay for this junction. It's going to be just 0.1 or 1 millimeter. Okay, so can't apply this size on this area. So have an error. Okay, so we need to change this one to at least 2 to here, find it 0.1. Very small. May take time, may no. See, mesh. It's fancy, right? Meshing. May take time. I think we can cancel it and create another.
Remove that one. Only the post.
Yeah, only this
One post.
one post. And it. Yes. Listen to. Thank you. Let's create mesh. You can do another thing. In standard, you can convert it to curve or blended. Blended can run. May run. Calculate minimum size of element. Include calculate minimum size of element. You need 6.1. Apply and go check. May okay. Maybe okay. Yes. Go. Just ratio direct to display. Wallah, no. Don't know. Okay. Good. Past. Problem past. Okay. Right click and run. Just run. Sorry. Delete. Run. This favor stop medical difficult response when you check the pound and the condition. Okay. Like we said, we will remove this post extra. Okay. But it's very important for us, but we can do something good. I need this extrude, but this small value is very difficult. It's okay. To serve computer, we will change the size of this one.
Just the engineer that always calculate to us, just only solve only that one, only the figure.
You need only the panel?
Oh yes, because when they send a load calculation in Saudi Arabia, they just only solve only one unit or something like that.
You haven't any other columns. You have one column only? Do you mean?
There's something like that. They don't put in the panel. I saw in the load calculation of that one time. They don't have the panel. They have only the every holding something like that.
Yes, okay. This means that in Saudi Arabia they have already the structure.
No, sir. They send our design to the engineer in Saudi Arabia to complete the calculation of the holdings.
Yes.
But I didn't show in the load calculation that was the panel. Yeah, only there is the base and the
Yeah.
structures only.
Yeah. This means that you not need banner.
Yeah.
Oh. Okay. You can make it. You need calculation on this one only.
Yes.
You need that. Yeah. And mirror on this one. Yeah. Okay. You will change fixation. Okay, sure. Only this 4 because first, and this pressure will be the same, but will be here. Okay. When make a pressure here, you have two types. You can make a pressure round, okay, but you can do it no. I can make it normal to selected face, no, reference geometry, so I need it parallel with this one, okay, and here normal to plan and reverse direction, okay. Okay. Also, right click, add graffiti. The normal graffiti, ground graffiti. It's very important to get accurate simulation. You have the graffiti. Okay, it should be added because it's very important factor. And run. Have see. Okay, let's read the results and no. Right click, edit definition, change floating, and change units to be like that. Displacement, the same, edit definition, change floating, and millimeters, okay, or centimeters to be the same. Change the unit. Let's check. Maximum deflection of this column at the red point 0.009, nothing centimeter, 0.009, nothing centimeter. And stress, you have almost near to 0. Why? Because you haven't any flat. You know, if I have air and will go through this one, the air will be distributed. You haven't flat, haven't impact. Okay, let's add an impact and see the result. Okay, now I will capture to you this one. I will capture it. Okay. Where is saved? Where saved? What's this? Okay. I have another. Step recorder, no. Yes, this one. I will record this image before and will record this image of stress plotting also before stress. Okay, and make our changes. We will create a panel. Only like that, not big. Okay, from offset, change the position from here to, for example, this one. Let's check again, static. You will change the pressure from this point to be on this point. Okay, and this way you haven't normal selected to phase, select here, reverse with same value of wind load. Run. Let's check. .058 increased. Deflection has been increased, and the load has been increased on this point. If we return with where it's before, 0.09, 009, it's been nothing effect. Okay, the main problem not in the column of structures in unipole and T-poles use. The problem not in the column itself or structure, because structure is a hollow, just wires. Okay, if I will put this with 40 millimeters angles with 40 by 40, for example, and affect any window on it, no effect. Very small effect. Okay, but the problem when you face a solid face like banner act a big force. Okay, so here fine, the same column with the same size, with the same base frame, but see the value 0.009, nothing. Okay, nothing load, no load. If you had also the stress, see the stress maximum in red, but you haven't reached to red. Now you are in 0 in this area, 22 to 44 in this range, and here you can see and check the stress. Where is it? Load, sorry, and check here. See maximum stress. Where is the maximum stress? Here. See, it's very hidden area. Where is the maximum? Read the number 986. I know that it's safe because it's very far from this number. Okay, but the concept that act force, act a very force. See where is the main force has been acted. In the direction of load. Why? Because here you make tension like that. Tension, the screws need to pull up, from floor. Okay, so you have the maximum resistance here, and this number is very important. If this number of this small point exceed, or at least have less than 10% of this value, it's not safe, because the standard safety factor in norms starting from 15%, 15%. Okay, understand this point? Clear? Also, if you will change the size, you will increase the stress. It's very important. So the problem, again, the problem not in T-pole itself. The problem in T-pole or unipole after install the pump. Because you have a fully solid area, a fully phased area, face the wind, face the load. Okay? And the very important also in calculations, the concrete specification. And this can be done by civil engineers, not us. We are mechanically. We're using this mechanically we can use steel. Yes, we can know the mechanical properties of steel. But in concrete, you should have a civil engineer that know what type of concrete, because concrete is the chemicals, like cements, like some stones have a issues between them. Okay, not our study. All right. Pending, it's very important. You have here a pending 0.058, but it's okay, it's already safe, because after wind load will be 0. Okay, all these beams will return to its place normally. You are in elastic zone. Okay, clear this point? Good. Okay. Now we will jump to sheet metal again. Okay, to show you if you need to make a louvers that you have in your charging station. You have a louvers in the door, some openings for air, for ventilation, something like that. Okay, if you need to make any shape in your sheet metal, so it's okay. Can I jump from set analysis or no? You have any queries in something, we can. Okay. You have sheet metal, piece of sheet metal, specific thickness. Okay. Now I need to make it with stamp. I need to make, for example, something like this louver. Okay? It's very clear for all, no? Hector, you saw it? Yes. Above, you saw it? No, you should know because you are very tired now.
Better you can show it in the Google chat. In the Google so that
Yeah. Okay, understand? It's a real tool.
So there's an under that something like that.
Yes. Have a punch
Yes.
under this lid. See. It's okay. Another type of louvers. And this flat area have a springs. Alright? This is a louver. Okay? Clear? Good. If I have sheet metal like that, if you go to your library, design table, design library, sorry, currently installed, not this one, this one is mine, but this standard table, standard library, forming tool, and check with louvers, for example. Good. Okay, so haven't any effect. Why? Because first time you will open this forming tool, you should right click and tell the software that this folder is a forming tool. Click OK. So go again and start drag and drop your tools. Okay. Flip it. Alright. When you go this tool and click on this one, first sketch, which point you create, meaning another tool. Okay, and you can select, sorry, you can adjust your dimension required, for example. Working normally. Okay. And you can right click edit and flip angle up to you. Change angles. You can control it normally. Alright. You have here a lot of tools. For example, you have impulses. It's a big one. I don't know why it be like that. Impulses. A lot of tools here. You can get one right click, edit, also it's sketch. Can put it here. Dimple. That. A lot of types of tools. It's mine. This is my special tool that I made, and I will see you how you can create your special tool. These lancers like that. A lot of shapes. Okay. This is a standard forming tool. Okay. All right. But now we need to create our forming tool. You have a special tool, have an order, have a special tool. You need to make your logo, for example, Unigraf text as a pressed, can be punched, and you will make a die and have a press here and got it, tuck. Okay, if you need.
Sorry.